This is a double layer printed circuit board and it had two defects. The defects are now resolved, they're fixed. I've intentionally recreated one of the defects so that I can demonstrate better the thought process involved in the repair of this board. I've decided to recreate the defect, which was easier for solving because it involves an electrolytic capacitor. The other defect involved this IC here. Originally, this IC here was not getting 8 volts VDD on this pad here. So naturally, what I did was desolder the original IC, hook up the board to power supply and measure whether those 8 volts would be present at this pad here with the board hooked up to power supply and the IC desoldered. But even with the IC desoldered and the board hooked up to power supply, I was not getting 8 volts here. The next step was to solder a replacement part. This is the replacement part, the replacement IC, hooking up the board to power supply and measuring whether those 8 volts would appear on this pad here. But even with the replacement part, those 8 volts were not present. On my finger here is the original part which was desoldered. So as I said, even with this replacement part here, I was not getting 8 volts on this pad here. Anyway, I've decided to keep the replacement part soldered to the board, and the next step was to use my multimeter, set it to continuity mode, and using the probes to try and probe where this pad here emerges next on the board. And what I found out was that it emerges here. Yes. So now my attention shifted to this section of the board here, and the first thing I did in this section of the board here was to replace this element here. This is some kind of a voltage regulator, and even after replacing the voltage regulator and hooking up the board to power supply, nothing changed. I was still not able to get 8 volts here. So now I've decided to analyze a bit more the vicinity of this element here. Moreover, because this area here lies directly beneath the voltage regulator, which supplies voltages for every IC and element on the board. And I've decided to check this element here because this is a resistor. This is a resistor, this and this, these two are capacitors, and they're not likely to fail. If they fail, they will fail very, very rarely. So that's why I've decided to check this element here. This is a Zener diode, and after hooking up the board to power supply and measuring the voltages on the pins of this Zener diode, I've realized that these two pins here were without voltages. Only this pin here received voltage, so that's why this element suddenly became the most suspicious one. And I've decided to replace it. This is the replacement element, the replacement Zener diode. On my finger here, this is the original Zener diode, which was, as it turned out, malfunctioning. So after soldering this replacement Zener diode, I was and hooking the board to power supply, I was finally able to measure 8 volts VDD here. So that was the solution to the first problem, a defective Zener diode. Now for the second problem, I will hook up the board to power supply and demonstrate the second problem visually, the second defect visually. But while the board is connected, I will measure the VDD voltage from the first problem so that you can see. This is my multimeter. Okay, so that you can see that we are getting 8 volts. Yes, so now we are getting 8 volts. Okay. As to the second problem, now I will demonstrate the second problem visually. Pay close attention to this servo motor here. I will feed control signals to the board and this servo motor will swing. As we can see, the servo motor swings around a desired position, and this behavior is not acceptable for this kind of board. For this second defect, this second problem, initially I used my multimeter set to continuity mode and tried to find where the connector for the servo motor goes on the board. Meaning I was trying to find which copper traces were leading to the connector for the servo motor and testing the elements along the copper traces. The first two elements which I replaced were these two ICs. These two ICs are the replacement ICs. The original ICs are here. So this is my first original IC which I desoldered. Okay, and this is the second original IC which I've desoldered. But even after replacing the ICs, nothing improved. So my next idea was to check the electrolytic capacitors. Moreover, because the datasheet for this voltage regulator here, which supplies voltages for the entire board, said that any change in the capacitance, in the nominal capacitance of this output capacitor here, might cause unstable operation of the whole board. So that's why I immediately shifted my attention to this capacitor here. And what I did was I found a small, relatively small capacitor, namely this capacitor here, 6.8 microfarads, and I've decided to solder this small capacitor, yes, in parallel with the capacitor, with the output capacitor of the voltage regulator, and that turned out to be the solution to my problem. Now I will solder this capacitor once more. Okay, and demonstrate the massive improvement. Let me double check that the polarity is correct. Okay, now I will hook up the board to power supply and control signals. Now pay close attention to this servo motor here. It will not swing. Yes, as we can see, it holds still. Okay, so that was the solution to the second problem, and all in all this was a brief explanation as to how one might follow the thought process in order to repair a broken electronic board. That's all. Thank you for watching.